Bore da pawb, good morning everyone. Welcome to the Royal Commission on the Ancient and Historical Monuments of Wales' Digital Past Conference. This is the third workshop of our week-long event, droning on a practical introduction to drones and archaeology. This is organised by the CHERISH project, a European-funded project led by the Royal Commission in partnership with the Discovery Programme Centre for Archaeology and Innovation Ireland, Aberystwyth University, Department of Geography and Earth Sciences, and Geological Survey Ireland. Leading the workshop will be Daniel Hunt. Ymunodd Daniel Hunt ar Comisiwn Brenhinol yn 2017 fel ymchwilydd archeolegol amser llawn ar y prosiect treftadaeth arfordirol CHERISH. Cymhwysodd Dan fel peilot UAV wedi ardystio gan y CAA yn 2018, ac yn sgil hynny, bu'n arwain y gwaith o ddatblygu arolygon drôn yng Nghymru i CHERISH, gan oruchwylio ac ymgymryd ag arolygu archeolegol a phrosesu data 3D at bwrpas monitro arfordirol a chynhyrchu deunyddiau estyn allan. Fel archeolegydd tirwedd, bydd hefyd yn defnyddio technegau arolygu eraill, megis gwneud arolygon dadansoddol o wrthgloddiadau a laser sganio daearol. Daniel Hunt joined the Royal Commission in 2017 as a full-time archaeological investigator on the Coastal Heritage CHERISH project. Dan qualified as a CAA-certified UAV pilot in 2018 and has since led the development of UAV survey in Wales for CHERISH, undertaking and supervising archaeological surveys and the processing of 3D data for coastal monitoring and outreach materials. As a landscape archaeologist, he is also skilled in using other survey techniques, such as analytical earthwork survey and terrestrial laser scanning. We ask that you please keep your cameras and microphones off until invited to switch them on by the workshop panelists, but feel free to leave comments in the chat for our panelists, and I'm sure that they'll go through them at the end. Welcome, Dan. We'll now hand over to you for this event.
Okay. Good morning, everyone. Can you all see my screen?
Yeah, we can.
Okay, brilliant. Okay, so yeah, my name's Dan. I'm going to start off this morning. So welcome to our workshop, Droning On, the Practical Introduction to Drones in Archaeology. I'm also joined by two of my CHERISH colleagues who are both based over in Ireland. So we have Rob Shaw from the Discovery Programme and James Barry from GSI, Geological Survey Ireland. And we're both going to take particular points of this workshop. So our aims this morning are basically to give a broad introduction to how UAVs are used in archaeology, some of the key factors that you need to consider if you're thinking about opening or starting your own UAV operation for archaeological survey. We're going to also explore some case studies. So Rob and James later in the workshop will explore some of the different uses for UAVs and how we've used them in CHERISH. And obviously this is a workshop, so we want to make it as interactive as possible. We want to learn from each other's experiences. So throughout the workshop, there'll be opportunities to share a few ideas at certain points and have some discussions. So yeah, so obviously we want to make it as interactive as possible. So we would ask that during the presentation parts of the workshop, if you have any questions, to put them in the chat box. I mean, there's 3 of us here, so there's always going to be two of us spare to answer any questions. And if you want to ask a question directly to the speaker and the part that they've been specifically talking about, there'll also be opportunities after, sort of short opportunities after each of the sessions, the short sessions. Where we could put the questions direct to the speakers. There'll also be a few more interactive elements. So, for example, planning your own survey and a few sort of polls as well. So with that, I just want to launch the first poll. So if Scott could launch the first poll, just to gauge the sorts of experiences and why people are here today. So hopefully you should have seen this pop up. So yeah, so why are you attending the workshop? Because you just have a general interest in UAVs. You're looking to set up your own operation with it as an individual group or within a wider organisation, or you regularly use UAVs and you're just interested in seeing how other organisations use drones for archaeological surveys. So I'll pop my answer in there as well. Okay. Have you got the results there, Scott? Okay, that's interesting. Quite an even split across the board then. So yeah, so hopefully with that in mind, we should have a bit for everyone in this workshop. So the first part will look more towards the general introduction to UAVs, and then if you have more experience in that, then we'll look at that more towards the end. Okay, great. So here's the broad outline. So I'm going to start things off by providing an introduction for UAVs in archaeology. And then my colleague Rob will look at a case study involving mapping archaeological sites in smaller landscapes by looking at a case study over in Ireland, Glascarrig. And then we'll finish up by looking at another case study presented by James, looking at larger coastal mapping and also how we're able to use the data from larger areas in a piece of software called Cloud Compare for looking at erosion and changes in the landscape and the coast. So first off, I'm just going to, so my bit's going to be broken down into these 3 bits. So the applications, what we use them for, setting up a UAV operation in an archaeological context, and then broadly planning, executing, and archiving a survey. So in terms of how UAVs are used in archaeology, those of you who attended the conference yesterday would have seen or may have seen the presentation by other CHERISH colleagues, Louise and Kieran, about our interdisciplinary approaches to the coastal zone. And UAVs obviously form a core part of that, but they form just one part of the overall approach. And this graphic here just illustrates the importance of applying a interdisciplinary approach. UAVs are fantastic for particular things, as we see throughout the workshop. But there are certain things that UAVs can help with in recording certain aspects of the coast or any landscape for that matter. So there's pros and cons and benefits and limitations for all methods. So just going through the applications now in archaeology. So first of all, we can use UAVs for low-level aerial photography and site inspection. So this is a low-cost way of inspecting sites remotely. It's a safe way of inspecting sites, and it also provides us access to areas where archaeologists or surveyors are unable to access safely or easily. So in the context of the CHERISH project, where we're looking at climate change and how it's affecting coastal heritage, this application is crucial because obviously we're monitoring changes, and sometimes even a visual comparison of change is all you need to sort of give the message that there's change and for the most impact. So, for example, at the bottom of the screen here, you can see this is a site up in North Wales, Dinas Sinclair, which is suffering from huge amounts of erosion. And you can see just by taking basic aerial photography with a UAV that we wouldn't have been able to do through other methods, you can see that there's been huge erosion. So it provides a fantastic, simple but effective way of conveying change at the coast. Also, archaeological prospection. So prospecting in different ways. So first of all, we have the objective data capture, 3D data capture. So we can use processes, mainly photogrammetric processes. So that's using overlapping photographs to create 3D models of sites and places. And this can be used to look at the earthwork remains, so the stuff that still appears on the surface. So here, this is Dinas Sinclair again. You can see this is some 3D data set collected for UAV, and you can see the defences, the earthworks inside, and how this kind of survey can show stuff, especially on the interior there, that's not very visible on the inside, on the ground when you're looking at yourself. Yep, so UAVs can also carry different sensors, such as multispectral and LiDAR sensors. This is something that we don't do so much. It's still a fairly expensive way of using UAVs, but just as effective. And can also be rapid response for situations such as drought. So obviously, one key overriding archaeological technique is aerial survey through manned aircraft, and a colleague, Toby Driver, does that as his sort of primary focus. But we can also use UAVs to look at more localized areas and use them as a rapid response in a more localized manner. And it's important here to also point out that UAVs, although they're fantastic things to use, they'll never truly replace traditional aerial survey, where you can cover large amounts of areas or parts of the country in short space of time. But they're fantastic. Where they are good at is looking at the more localized area. And here you can see this was the droughts from a few years ago, and there was numerous discoveries both in Wales and Ireland, using drones in collaboration with manned aircraft. So there's the benefits of that for prospection. We can also use them for wider landscape capture. So this is something that James will discuss a little bit later on. So a similar way to how I described using the photogrammetric processes or any 3D data capture. We can also capture that sort of data for larger scale sites, which contextualizes the archaeological sites within their wider landscape, and you can extend monitoring or prospection further afield. And yeah, so for fixed wing aircraft, which I'll talk about a little bit in a bit, is more suited for the wider prospection there. And obviously for CHERISH, site monitoring, as I previously touched on earlier, UAVs are fantastic at doing this kind of work. So for quantifying change, loss, how much of a site we've lost. So this is a site over in Ireland called Dunbeg, which has suffered hugely from coastal erosion. As you can see it down at the bottom there, it's between some of the archival plans, the 1898 plan, between some of the UAV surveys up till 2018. There's been huge amounts of loss there, and by And by generating models and 3D data, we can quantify the volumes that have been lost. And this is a site that is now closed to the public because of the sheer amount of erosion that's going on here. And perhaps most importantly, we use the outputs from the UAVs are also really effective in outreach. And this is also something that's very important in CHERISH, but also in the heritage sector and archaeology, for getting out the message of, you know, what's out there and the archaeology around our coastlines, countries, landscapes. And there's something about a UAV image or a video that really appeals to people, and I think it's because it's a unique perspective that people can't get when they visit these places on the ground, and people really enjoy seeing them in that way. Also, we can use the data we collect, the objective 3D data, to produce 3D models that can be interacted with. So this is a Sketchfab model. I'll see if I can load it up. Should be able to see my screen there. So this is Dinnersley again, but we've got ones for several other sites. So we upload these onto the Sketchfab for people to look at. Then you can also scoot around, and there's information about the archaeology, what you're seeing in the model, and some basic information on the landscape and the geomorphology and the erosional processes that are happening, and why this particular site is being affected by coastal erosion, climate change. And lastly, so also going out into schools, not only to present the archaeology, but also to inform on how UAVs are used, which is important because they're becoming more increasingly used as years go on. So now I'm going to move on to the setting up a UAV operation. So if this is something that appeals to you in terms of you're looking to start your own UAV surveys and getting in the air, recording archaeology. Yeah, so obviously most importantly is the UAV, the choice of UAV and what you're going to use it for. So primarily the ones that I use are the ones you see in the top left there. So the quadcopters, this one's a DJI Phantom, which is our kind of workhorse. But you have two broad groups there. So you have the multi-rotors, such as the Phantom you see there, the ones with the multiple rotors, as the name suggests, and the fixed wings. And they both have their own advantages and disadvantages. So the multicopters generally are used more for site-specific and smaller landscape and site surveys, photography, if you need a stable platform for photography. And the fixed wings are used for more rapid, larger data capture photography. And these are the ones that also have the larger range from the pilot. So if you have specific permissions allowing you to fly beyond line of sight, these would be the ones that you would usually use. But also to consider, as well as just the drone itself, is also the equipment that goes along with it. So if it's just for photography, then obviously you're not gonna need as much equipment, but you're still gonna need batteries, you're still gonna need carry cases, and the safety equipment is required for you to operate safely as well, such as fire extinguishers, fire blankets, because UAVs at the end of the day are hazards, and fire hazards they can be. The batteries can be particularly volatile sometimes. So all of this has to be taken into consideration when thinking about setting up your own operation. And if you think about, if you want to use them for the 3D data capture, you also have to consider the survey equipment you'll need for the job. So the basic equipment you need is the GNSS. You can see me holding it there in the top right. And also the base stations and stuff that goes along with that. So it's all stuff that needs to be thought about, and all stuff that can be tricky logistically to get to site. I'm just going to go into now a bit about the kind of the regulations that you need to think about while setting up an operation. I'm going to be coming at this from a UK-based perspective. So I know that there's vast differences across countries, but this is just going to be a bit of a grounding of what we do here. So yeah, this is just to make the point that this is the contents of a training manual that you're handed at the start of your training course, which covers everything from air law, aircraft knowledge, and meteorology, so even the weather. And obviously, I'm not going to cover all of this, but we'll touch on a few of the key aspects. So one of the major recent changes in the UK is the fact that all UAV pilots are now required to register their UAVs with the Civil Aviation Authority. And this came in November 2019. I think Ireland was ahead of the UK in terms of requiring compulsory registration, but now all users are needed. So this is what you're presented with as the overview. So everyone needs a flyer ID and an operator ID. So if you're an individual pilot, you need both. But if you're operating within a organization such as CHERISH or a different one, then you need one operator ID, and then each individual pilot requires their own flyer ID. And how you get this is just through a simple kind of Q&A test, and it's all automated for a small fee. I think it's about £8 or something. So it's not too much to ask. But to get through the test, you need to have a knowledge of basic flight safety. So these are just some of the things that you have to think about. Basic flying rules in the UK. So if you're using a UAV, it always has to be in line of sight. It can only get to a maximum flying height of 400 feet to avoid sort of the busier corridors in the higher altitudes. And proximities. Now, this is something that's changed recently with the new rules that I'll talk about in a second. They're set proximities. Now you're not allowed to fly over any crowds of people or any people, and this is one of the things that has changed in recent months, where certain trained pilots and certain drones were able to safely operate in a kind of a bubble over people, whereas now it's a straight no fly over any above any groups. So yeah, so here you can see some of the basic rules. So don't fly closer than 50 meters to people, never fly over crowds, and keep 150 meters away from residential, recreational, commercial and industrial areas. So the CAA has really tightened up on certain safety aspects in previous months. And perhaps the biggest one is avoiding airports. This was something that came in after the some of you may know about the Gatwick incidents and the Heathrow drone incursions, or so-called drone incursions, even though I don't think they ever found the drone or the pilots. But they extended the restricted zones around airports, and also extended you see these 5 kilometer buffers off the end of the runways to prevent anyone getting anywhere near these places. In the UK, the air navigation order underpins all of navigation law, and including UAVs. So it's an essential read if you're thinking about going into this, and this would be something that you're directed to by a training provider if you're going through the training. So the new rules in the UK, they were meant to be introduced first in July 2020, but were delayed obviously by the pandemic. So they eventually came into force on the 31st of December. And they essentially replaced this distinction that previously existed between commercial and recreational flying sort of spheres, which was determined by if you're operating commercially, you're required to get this thing called a PFCO, so permission for commercial operations. But that's no longer the case now. And as you can see here, the training qualifications are now, they relate more and they're determined by risk of environment. So the how, where, and what you're flying now determines the level of training and where you can fly, rather than if it's a commercial or recreational endeavour. And the two main new sets of training that now replace the PFCO are these two here that you can see. So the A2 Certificate of Competency, which offers similar flexibilities to the old commercial licenses, and the General Visual Line of Sight Certificate. So this is slightly more advanced certification. And yeah, so if you go through with the training, it's always important to keep good relations with the training provider. I mean, I'm still in regular contact with my provider way after I qualified, and I know James and Rob are also in regular contact with their provider, because they're the guys who stay up to date with all the rules and stuff, and they can keep you in the loop. So the new operating categories for flying are the ones you can see here. So you have the open category, specific category, and the certified category. And yeah, so they're all three of them are determined purely by risk. So broadly speaking, the one that the majority of people will be operating in will be the open category, which presents low or no risk to third parties. And this is the category which is defined by the basic kind of restrictions that I showed a bit earlier. And when you move up through the categories, it gets more and more tricky. So for example, in the specific category, as soon as you can, or the operation that you have planned is unable to keep to one of the limitations, such as I don't know, the altitude you're flying at, you need to fly higher, or you need to fly beyond line of sight, then you'll need to move into the specific category, and you'll need specific permissions directly from the CAA, so the UK Civil Aviation Authority. And then the certified category is way up there. So yeah, operations that are equivalent and have the same risk as manned aircraft. So you're talking about the much larger UAVs and the much more complex missions. And within the open category, there's also subdivisions of what you can do and the types of UAVs you use. So these largely determined by size and weight. So as you can see here, the heavier and the bigger they get, the more restrictions within this category. So the smaller ones, in certain circumstances, you're allowed to fly with uninvolved people, which are people that you haven't agreed that you're carrying out survey with, general members of the public that could be out walking, that kind of thing. And as you move up, then the limitations start coming in. And you can see on the side there, as examples of the new categories that are going to be coming in within the next couple of years. Each drone that's produced will have a standardized category, so the A1, A2, A3 operating in this class. So that will be phased in over the next few years, so something to keep an eye out for. So in terms of archaeological survey, there's also other considerations such as landowner permission. So for archaeology, we in Wales especially, we deal with a lot with the different agencies such as national parks, National Trust, and in Wales CADU, but in England it could be English Heritage or various different custodians of heritage. And these organisations have different restrictions, their own restrictions on what you can do. So some ban drone use outright unless you get specific permission. Others provide even more kind of stringent measures, and these are things that need to be considered also when thinking about the types of survey you want to carry out. But so what is the purpose of tightening the rules? I mean, obviously they're for safety purposes, to keep people safe, stop people getting hurt. So you can see here the Gatwick instance, and there's been various times over the last few years where drones have been in the news for probably negative reasons, and obviously the CA have responded to this. But also with the Royal Commission, we're a national archive as well, and we have our own rules for submission of aerial photography now, because we've become aware of the fact that a lot of people are taking, even though they're taking lovely photos, that they've been taken in what would be considered dangerous ways. You know, that they're not abiding by certain regulations, aerial law, that sort of thing. So we've had to tighten up what we can accept and the evidence that's required, because it's all about the perception of organisations as well. Will be seen to applying best practice. So here's the first interactive element of the workshop. I thought I'd throw in a bit of a quiz. So Scott, if you could throw up the poll. Okay, so each of these has one right answer. So we have the first one. Max flies his drone behind a group of tall trees. His drone is out of sight until it comes out the other side. Is this safe? The second one, what are the visual line of sight dimensions in terms of height? What defines somewhere as being in the open category? When do you need to register you and your UAV with the Civil Aviation Authority, obviously in the UK? So I'll just give you a minute to think about those. Okay, so get the results up. Great. So there you go. So you can see the answers there. So Max flies his drone behind the group of trees. His drone's out of sight until it comes out the other side. Is it safe? No, because he must always be able to see the drone. And that's one of the most important rules. The visual line of sight is, yeah, so it's 500 laterally, 400 feet above surface. So visual line of sight. So if the maximum distance it can be away from you is 500 meters. So as long as you can still see it, if you can't see it at 500 meters, you need to be flying it closer to you. Yeah, what defines somewhere as being open category? A place where operations present a low or no risk to third parties. And yet, you always need to register your UAVs. Great. Okay, so the final bit for my section would be just going to run through an example of planning, executing, and archiving a survey. So we'll be looking at a site in Pembrokeshire in Nab's Head, which is a Mesolithic flint mapping site. So as you see here, it's this headland here, which is eroding away at the top here. So this is why this is one of our monitoring sites. Yeah. So if you're familiar with Pembrokeshire, this is to the south of St Bride's Bay, and this is Scomer Island, where you can see all the puffins in Nab Hedge just here. So yeah, I'm just going to scoot through this, but I know Rob will be talking in more detail about a bit about going through this process as well. But in terms of before you go out to a site and you want to do a survey, you're required to carry out a pre-site survey, which looks at different aspects, as you can see here, such as the airspace, hazards you might come into contact with, even livestock that might be present in the area, and perhaps most importantly, the weather forecast, which can be a goer or stopper for any drone flight. So this is what we do before we even set out into the field. And this might also be accompanied with a reconnaissance visit if the time allows. But a lot of this can be done remotely, which is good. And in terms of using remote methods, these are some of the key tools we can use for checking weather and airspace restrictions before going out. So we have Sky Demon Light, which is the main kind of aerial mapping, which shows all of the airspace restrictions, such as airports, military bases, and NOTAMs, which are temporary notices to say that particular airspace is restricted. Drone Assist also assists in doing this, and yeah, the use of various weather apps. It's always good to use different weather apps and not just rely on one, because as we all probably know, especially in the UK, the weather is pretty unpredictable. So it's good to get a general idea by using several different weather apps. And yeah, also in the coast, especially, but also at other locations, no doubt, is the consideration of wildlife. And we have this particular, well, not issue, but we have a lot of nesting choughs which are protected, and they're very prominent in Pembrokeshire, which during nesting season, this grounds all of our drone flights if we want to fly in particular wildlife areas. So this is another consideration we have to bear in mind as well to plan our surveys, not only around the weather, aerial restrictions, but also around wildlife and the various protections in place. So when we actually get onto the site, it's always handy to have a pre-flight checklist to set up your UAV. So you can see here there's various quick checks, such as looking at the airframe, your satellite coverage for the surveys, the state that your gimbal's in, the quality of the video feed. So all the basic things that will ensure a successful survey. And it should also be armed with a risk assessment, which is the case with all field work, but especially important with drones, where there can be a bit more that can go wrong. And then, yeah, the next step after you've checked things over is the on-site survey. So this is a kind of a final check when you've got eyes on the ground. If this is the first time you've been on the site, this is a very important step to just check that everything is as you expected. To check the weather conditions are suitable for for your flight, and to identify different areas which may pose difficulties. So there might be some hazards that may not have been picked up on the pre-site survey that need to be mitigated when you're on the ground. And yeah, it's always important to have the contact details of emergency services, so such as the police, local air traffic control, and the hospitals, just in case anything does go wrong. You're required. So such as if the UAV decides to start flying away, you need to be ready to inform air traffic control. So yeah, the next sort of interactive part is to try and plan your own kind of flight. And I've got to I can't share now. If I just share a link to a sorry, I should have done this at the start. Yeah. So if I copy this into the chat box, I should be able to access. Can I not access? Oh, there we go. There you go. So in there, you should be able to access a set of files, and in there is a couple of the forms, so the on-site survey and the pre-site survey. So this is just a quick exercise to fill out a pre-site survey of Dinner Sinclair again. So you can see a map of the general area, some things that you may have to consider, along with some of the ownership and the protections there. So yeah, I'll give you a couple of minutes. If there's any problems accessing the files, then let me know. And then after a few minutes, we could have a bit more of an engagement in terms of raising hands, and we can hear some of you, which would be good. So I'll give you a couple of minutes for that. Okay, I'll give one more minute, and then we'll open it up for a short discussion. Okay, so does anyone want to be brave and raise your hand and say what we should be looking out for when we're planning a survey for this site? If you want to raise your hand and at the bottom there. If not, then I can just walk through. Okay, no one's being brave, but we have a comment yet. So in the chat. So yeah, the airfield is a big thing for this site. So when planning for this, you'd obviously have to take that into account. You'd have to contact the air traffic control, which we've successfully done several times. Sometimes they're able to set up a temporary notice, which will allow for any aircraft coming in to know that there's an operation going on down at the hill fort down here. Yeah, obviously it's a publicly accessible monument. In the summer, the beach gets really busy. This is just south of Carnarvon, so it's quite a busy holiday area. So this whole beach will be full of people during the summer. It's also got the Welsh coastal footpath. Yeah, so the coastal footpath is coming over the top of the fort. So you have an issue of the public coming over here. So you'd have to think about how to deal with that. You can, if it's a particularly busy day, then you may have to bring in a cordon. But if it's quite a quiet day, then it's enough just to be able to inform any people coming over the hill fort that there's a drone operation going on. Yeah, the wireless mast. Yeah, that's a good observation, which should be something that should be looked at. Could be an obstruction if you're flying that part of the beach. And yeah, the caravan park. So obviously in the summer, there's a lot of people going to be on their holidays there, and although you may not be looking to fly over the caravan park, there could be a privacy sort of issues there. So it may be worth informing them if it's during the high season. We've usually flown in winter time, so it's usually been closed, which has got around this. And yet the wildlife, yeah, there's issues of nesting birds in the sandy cliffs there, so that limits us to particular times of year. And yet the land permission, so we work closely with the National Trust, who allows us to carry out surveys on this. And also it's also worth, because it's a scheduled monument, more out of courtesy than anything, it's worth just informing CADU or the local inspector that you're undertaking a survey of their site. Is there anything else? I don't think there is. No, I think that's covered it. Great. So just to quickly wrap up my bit, I won't go into too much detail about this, but is the archiving. So after the survey, you have to consider how we're going to archive it, which is a big issue in the UK anyway, where we still struggle to deal with 3D data. But we have some guidance from the ADS, the Archaeological Data Service, of the sort of metadata that we should be storing. So you can see here, we've got different levels of data here that we need to store. So the survey level stuff, so it's all the stuff on the day. This is all important because if the survey is to be extracted from the archive in 10, 50 years or so, it's important to know sort of its provenance and how it was undertaken. So you can see here there's various important information that should be considered, and the image level stuff. So this is usually embedded in the image themselves. So the archiving, there's guidance, but there's still issues here. So so this is something we're trying to address in CHERISH, kind of by putting together these patches. So we have all of the photos. So this is a photogrammetric survey. So we have all of the photos, all of the flight reports from the day, so we can pick out some of the information we need, and then some short reports just outlining what was done on the day, the positions we had, and stuff such as the survey ground control and things as well, which will be something that Rob will talk about in the next section. So yeah, so archiving still causes us headache, and I think it will for a long time. But I think we're making some steps to address it. But yeah, it's something that needs to also be thought about when thinking about setting up your UAV operation. Where are you going to put all the data afterwards? Where are you going to put all the photographs? Because they can take up a lot of room. Okay, so that's my section concluded. We'll have a short break now, but I'll still be around if you want to ask any questions. Put your hand up or pop some stuff into the chat box. So yeah, so we'll have a short 5 minute break, if that's okay, and we'll see you back here at just before 11. Okay. Well, I hope we're all back. Are you ready to go, Rob?
Yeah, I'm ready.
Okay, brilliant. So I'll hand over to Rob now, who's going to give an introduction to or a case study over in Ireland, Glascarrig, in terms of using the UAV for mapping individual archaeological sites. There you go.
Okay, can you hear me okay?
Yeah, all good.
Good. Okay, this is a case study I'm going to present on work that was done by the CHERISH project at Glascarrig Mott in County Wexford. The outline of this case study, I'll just discuss briefly why we studied the Mott at Glascarrig, then look at the elements involved in planning the mission and what happens before we get onto site. Apologies for the chimney noises in the background, by the way. Got a strong wind here today. Following the planning element, I'm going to look at the execution of the survey, what actually happens on the day, and look at what we do with the data after we return to the office and some of the more detailed analysis that takes place. So Glascarrig is in County Wexford, North County Wexford on the Irish Sea coast. It's an Anglo-Norman motte thought to be from 12th century and is in an area of fairly soft sediment coast, which is eroding. It's not spectacular erosion like the example Dan gave earlier at Dunbeg, where we've got dramatic collapse, but we have this sort of creeping erosion eating into the side of the motte. There's good map evidence that the considerable amount of land has been lost, and we have also documentary evidence or not hearsay, but the landowner speaks of his father being able to drive a tractor around the edge of the motte, which is now falling into the sea. So it's a great example for CHERISH, interesting site and a dynamic piece of coastline. So in terms of mission planning, there's a huge amount, which I think Dan covered quite nicely from the UK point of view. In Ireland, we have very similar regulations and controls in Ireland by the Irish Aviation Authority. But essentially, we have to put together a package of documentation before we can really consider going out on site. In some cases, this is a requirement of the land owner if it's state-owned land, like sort of the OPW, the Office of Public Works, or National Monument Service, who would have to, before we'd be considered to get permission to supply a lot of this documentation. A lot of it's very similar to Dan pointed out, the pilot competency to prove that you're a qualified pilot, specific operation permission, which is a document which allows you to operate beyond the perhaps the visual line of sight. You'll be able to extend the line of sight, your operations manual, safety statement, insurance. Without these documents, we would be refused permission on most of the sites for CHERISH. This case is slightly different. It's a private landowner, but we would still apply the same rigor to our documentation. So we'd have all these certificates and documents in place. We then undertake method statement, general risk assessment, and the UAV specific risk assessment, which we'll look at in a minute. And obviously we'd engage then with the landowner and ensure that we had written permission before we proceeded with the survey. The UAV risk assessment is a new document which we're working with. It's part of our operations manual, and it really outlines in detail what's taking place in terms of the UAV operation. Of particular importance to this is really to try and ascertain what the airspace classification is and whether we actually will have permission to fly. In this case, we're able to go to our training supplier, Flyrite is the company who's supplied the Discovery Programme with training. With Flyrite, they have good resources online where you can type in the position where you're going to do the survey, and it will tell you what the class of airspace you're dealing with is. So in this case, it's uncontrolled airspace, so we don't have any specific reason to be engaging with the Irish Aviation Authority. Had it been controlled airspace, this is where we'd have to go through gaining specific permissions from Irish Aviation Authority, and that's where we have to have all the qualifications in place to put that application in. And the other aspects here are really just looking for potential hazards and likely issues which will add risk and add the need for perhaps mitigation to the survey. So this form, the pre-site survey risk assessment, then informs us onto the operational risk assessment form, and here we apply value to the risks which we've identified in the pre-site assessment. And it's some interesting aspects coming to this. It's a kind of cumulative risk assessment value, so it depends. There are ways of making this the score higher or lower. We can mitigate, we can try and bring in things to improve the score and to reduce the risk. But it's aspects like how many people we have on site, whether we have an additional operator who can help in being sort of another pair of eyes, that will reduce the risk. The amount of experience the pilot has had will reduce the risk. And if we can avoid having the customer on site, that reduces the risk. Other elements would be the equipment that we're flying with. If we're flying with octocopter, there's no redundancy in an octocopter. Sorry, in a quadcopter. If one of the rotors goes, that's the flight will fail. So obviously, if we can work with more rotors, then we're less of a risk. So all these things come together to give us an overall risk assessment. Other elements would be what we're actually intending to do with the survey. If it's simply photography, that's a low risk. But if we're providing a demonstration, or if we're doing cinema quality videography, the risk is increased. So we're always looking to minimize the risk and to put in place mitigation if there are things which we can identify. The next element is really to try and work out when it's going to be a good time to fly. And Dan touched on this earlier on. There are multiple sources of weather forecasting. And in the days ahead of the survey, it's always good to get some indication as to whether the week that you've identified for survey is actually going to be realistic. And then as you get closer, you can narrow it down to the day of the week that might be appropriate, and even the time of day. But there are other aspects about time of day which we'll talk about later. The other aspect, I suppose, is we've got these weather forecasts, like windy.com would be the one that I would tend to use. But we can get more information about our flying conditions through some of the apps that are available. This UAV forecast one is very good. It brings together information which is more than just the weather. It also talks about numbers of satellites, the visibility that's going to be there depending in terms of cloud cover. And it gives you an overall score broken down by the hour of the day as to whether it's going to be good to fly or not. So we tend to use the weather forecast apps in the days ahead, and then when you get to the day you've selected for survey, move on to the flying app itself. And then the next thing we'll be looking at is planning our flight. And this would be for a mapping project, which in Glascarrig we did the three aspects which would be interesting, which is mapping, oblique photography and videography. But this is probably our primary objective for most of our surveys, is to come back with photography which can be used in SFM processing to generate orthoimagery and digital elevation models. We use the DJI Ground Station Pro app to control our Phantom 4, and this allows us to determine the resolution that we're going to get from the eventual digital elevation model. So this has controls in it which allows us to set a flying height, the altitude of the drone, which will then give us the resolution of the photography, which feeds into the resolution of the generated digital elevation model. And by sliding the controls on this app, it changes various aspects. If we have a lower altitude, we're going to end up with considerably more photographs, which may require more battery time, more flying time than we have, and more photos than it's practical to process. So it's a balancing act really, and we're always bearing in mind that we want a specific resolution which will reveal the archaeological features, but we have to balance that up against the practicalities of the power that we have to fly the drone and the number of images that we can process. The other aspects would be to respect the Irish Aviation Authority rules. We don't want to start setting flying heights higher than 120 meters, which would be the restriction. And we don't want necessarily to have longer than 300 meter line of flights from the takeoff landing zone. Having done the qualification, we now have an extension to that, so we can fly to 700 meters, but it's still worth bearing all this in mind when you're running through the planning stage. And the other thing we consider planning is our videography. There are different approaches to video flying. Some people will just set the drone in the air and put the video on and maneuver it around and cover very numerous different aspects of the site in single video shoot. I find it easier to break it down into these sort of, my colleague gave me this kind of crib sheet where it has different sort of classic video elements, and I find it easier to plan which ones I'm going to use and to have in mind sort of storyboard for how the video will develop. So I'll have the pull away element or the panorama sweep, maybe the descend down onto the site, and then I have them as separate elements, and I have a tick list in the field of me of what I want to capture. The other thing to think about on any of these sites is the sun and the position of the sun with relation to the site, and in particular how that's going to impact on shadow and glare in your images. And this can impact quite severely on early morning, late evening time flying. It's an important factor to consider. It might affect the order in which we do the task on site. We may want to take advantage of a particular sun angle for the obliques, or we may want to prioritize having minimal shadow for our SFM element of the mission. So it's really important to consider, and this can be done in advance using the likes of the sun position apps and looking at Google Maps or Bing Maps. And then we're into the stage of actually going out and executing the mission and heading out. So we have a pre-embarkation checklist. The wind in the chimney again, where we're basically just going through to make sure everything is in good shape on our drone and that everything is charged. We have a card, all the maps are cached, because sometimes these apps like the Ground Station Pro, if you haven't cached the map and you find yourself in an area which has limited network coverage, you might not be able to access the maps you want. Important to check that there are no weather or airspace issues. That can be done again through our provider's website, and that making sure everything is packed and ready to go. Another aspect, I suppose, is that Dan touched on this, that when we're dealing with mapping projects, we're looking at having GNSS equipment. So we want to be sure our receiver is there, probably a base station, targets, batteries charged. So there's a lot of preparation and checking that needs to be done before we set out. The other thing on the site, then you want to start thinking about survey control. How many points are we going to put out? It's sort of diminishing return. There's value in adding points, but it becomes that graph there is just the number of points per 100 photos, and the error would be associated with your model. And at a certain point, it drops off. Where are we going to put these? That's part two. The major point that little graphic is trying to make is that it's not just distribution in terms of plan position, but you want to have distributed points in terms of height within the model. We want to use good markers, nice, precise, sharp markers, bearing in mind that the sun can provide glare onto these, so they should be good, crisp markers that will allow you to define the center point. Distribution is important, and this project actually highlights some of the problems that you can encounter. I was out without a base station operating GNSS off network corrections, and my quite important. Station 6, highlighted in red, was actually in a GPS shadow or GNSS shadow area and was unable to resolve the position. So instead of having 6, which would probably be a fair minimal on this survey, I ended up with just 5. So something to bear in mind. And then we have actually the pre-flight. So we've basically got our equipment, it's unpacked, it's on the landing pad, it's ready to go. And we just go through a number of checks just to be absolutely sure that everything we have is correct. And this is really just to ensure a safe and successful survey. So it's really important to have a final check for things such as power lines, obstructions, trees, any aspects like that. And the idea of dead ground as well, these are the areas where perhaps the drone might drift out a few. You always want to try and maintain visual line of sight with your drone. Other aspects would be the secondary landing site. So we do have issues occasionally where you might want to have an emergency landing site. And it goes on to the point where we're then telling the people around us that we're powering up, making it clear that the drone is now about to fly and to set everything off. So we're taking off. And this is where the Ground Station Pro app comes back into play, and it will essentially fly the drone for you. So if you press fly on the DJI Ground Station Pro, the drone takes off and it follows the predetermined flight lines. And if it's more than one battery required, it will return itself to home. So it literally just comes back and lands back on the pad automatically for you to change the battery and restart the flight, and it completes the complete mapping coverage. So that image down in the bottom right, there's just the flight lines as they come through. So we have our required overlaps that we need, lateral and forward overlaps, so that we have the data for SFM mapping. When flight's finished, we have another checklist. This is really just a safety thing again, just to ensure that nobody interacts with the drone while the rotors are still flying, and we make sure that everything's powered down, the aircraft's safe, before we then start to remove elements such as the propellers, battery, and the data card. So once we've completed our survey, we're then into the post-survey element of the project. And essentially, it's just starting to, first thing is to gather and to download what information. So 559, we took 26 video clips. So this data is then downloaded. My internet's just told me it's unstable. Hopefully I'm still running. And we go then to take our GNSS downloads. This would often include sketch maps of where we located, where we planned, and actually whether we surveyed the controls. I take photographs of the points just to help with identification. I would then download and export a CSV version of the coordinates. We also take our flight data records down, just so we have an archive of where we've flown and information, which can be useful. Just it gives you information on quality of the batteries, how well they were performing, maximum distance, battery temperatures. And this is stored on a system, an online service called AirData. We've paid a pro account on this, so it's not overly expensive, and it just allows you to easily maintain good logs of your survey data. So then into photogrammetric processing, we have been using Agisoft Photoscan, which is now Metashape, and this is a fairly systematic. I'm not going to go through in great detail on this today, but it's a photogrammetric processing system which works through a kind of alignment at various stages, starting with aligning the photographs, bringing in our ground control points, from which it's then able to build a dense point cloud. And from that, we're then able to generate digital elevation models, ortho imagery, and output these as products for further analysis. So we take our DM and ortho imagery into ArcGIS and mesh models, maybe into Geomagic. We're looking to move forward. We use photogrammetry in many other areas in the Discovery programme using reality capture, so there's a good chance that we'll be moving to reality capture for the aerial work as well in the future. And these will be the outputs that we have. We have the digital elevation model. This is 2 centimetre resolution, high resolution model, which really does reveal, I think, fantastically the topography and the elements of erosion eating into the side of the motte. In tandem with that, the other standard product from photogrammetric survey would be the ortho image. In this case, just adds texture and gives a little bit more depth as to how the site appears. In terms of video editing, we take our videos. We've been using simple Movie Maker in Windows, but I've been moving across to then Adobe Premiere Pro. And the idea really is to take the best bits of the clips that we've made and to generate a kind of video record. So in this case, in the end, only 9 of the 26 captured ended up in a 2-minute video. This would be, just run a little bit of this. This is the basic video that captures, so you can see that we've taken one of the simple arrival at the site from an angle, and then we'll splice that with views from above, which reveal the eroded northern face of the motte. And it goes on like this. So that would be a fairly standard, just simple video. But what we have found, and we've been doing, a more interesting approach to the use of the video is to develop a kind of narrative or embed it in a bigger storytelling exercise. So we've been trying to do this with more of ours to improve the public engagement. So you'll see there's elements of the video capture are included in the site here, but they're part of a bigger storytelling. We're using other aspects. So we're using ground-based photography. We've used some of the higher plane captured images and maps and such like. So we're able to use our drone imagery to help our drone video to try and help tell the story of the site and convey, why we're there and what value it is. So I think it works better really with that element, the added narrative. The other thing we do obviously is your obliques. There are an awful lot of them. There's a lot of repetition, so we normally try and select maybe 10 to 20 of them as the representation of the site, apply some Photoshop corrections, and they would be the ones that should go forward for inclusion in reports and on websites, but we'd always retain the others in case at some later stage there was some value to them. Surface comparison, this is the interesting stuff. I think this is where we see real value in the data we're capturing. So we've done 2 surveys at Glascarrig. They're relatively close together, but this was really just a proof of concept. The important thing is being that we ensure that both surveys are done at the same resolution, capturing the same area, same resolution, so we do the same parameters on the program in GroundStation Pro. So we end up with these 2 models which are remarkably similar. It's worth bearing in mind, I think, with the surface models that we're capturing from UAV capture is that it includes vegetation. This isn't LiDAR data. This does get affected by vegetation. So for that reason, seasonality matters, and the preparation of the ground or the agricultural practices taking place on the ground can make a big difference. So in this case, it probably isn't ideal to be comparing June data with February data. But regardless, we've been able to do raster comparison, and this is done in ArcGIS, and it really just shows that the technique works in the sense that we registered very little difference. The mean difference of the pixels when matched was a centimetre, which is really very good. And the only major differences were beyond into the beach area, which we would have expected, and some of the vegetation elements, the growth was different. This monitoring we're intending to be back in 2020 this year, 2021, to complete the comparison surveys. Just finally, really just some thoughts about the future with the UAV mapping and discovery program. It's very dynamic technology, and the regulations are changing all the time. So in terms of technology, we've got 2 Phantom drones now. So our original Phantom we're going to change to be a multispectral camera. The second one that we have is this RTK GNSS enabled drone, which means less control, which should be more efficient field work. And as Dan touched on earlier, there are LiDAR sensors for drones. I'm pretty sure in 5 years' time, less than 5 years' time, we'll probably be using LiDAR sensors, which will give us a different element. We'll be able to perhaps work in higher vegetation areas and still get our surface models. And we have to be aware software is changing. We're always looking to look at the best options for the software. And regulations and licensing, the Irish Aviation is moving to this Europe-wide EASA system, and this will have potential impacts on how we get and who will be able to get access to controlled airspace, which is quite significant for large areas of the CHERISH project. Okay, thanks for that.
Okay, thanks, Rob. I think as we're overrunning a bit, I appreciate that that we said we'd finish at 11:30, but James still has his part, which should be about 20 minutes or so. So we'll carry on with that. If you're happy to stay, then that's great. But if you need to leave, then that's fair enough. But I'll hand over to James now. He's going to talk about more wide-scale level of mapping on the coast using UAVs, more with the fixed wings. And he's also going to give an introduction to Cloud Compare, which is a bit of software that we can use for comparing different data sets collected, looking for erosion changes at the coast and quantifying that change. So okay, I'll hand over to James. And yeah, if you have any more questions, just keep putting them in the chat, and we'll get back to you. Okay.
Thanks, Dan. Thanks, Rob. Can you see my screen okay there? Maybe give me a thumbs up there, Rob. I can see yours.
Yeah, all good.
Super. Thanks. Okay, folks. So I'm going to give a bit of a talk. So I'm going to talk about why GSI got involved in drones. And then I'm going to go through a couple of case studies just briefly, but the main part of my talk is going to be an introduction to Cloud Compare, which is a free open source software. And there's a link to the software in a text file in the link that Dan provided earlier in a folder called Rosslayer with some sample point cloud data as well. So just if you do want to download it and install it, you could probably run through the example as I'm talking if you want. Okay. So first of all, I'm going to talk just very briefly about Infomar, which is Ireland's national seabed mapping program. So it's a 20-year funded project which aims to map all of Ireland's marine waters. So the approach that Infomar has taken is primarily using multi-beam sonar, which is a vessel-mounted sonar system, which sends pings of sound down to the sea floor and builds up a 3D image of the sea floor as the boats are moving along. Now, the issue with multi-beam sonar is that the swath narrows as you get into shallower water, as you can see in the diagrams here. So there's an area known as the White Ribbon, which is kind of the near shore shallow area, which is very difficult to get with boats. It's much more time consuming because if you imagine cutting the grass and you're going up and down, but getting smaller coverage each time. So we were looking at approaches to improve data access in the White Ribbon. So from 2015, there are a few advancements in technology. And we started looking at smaller boats to get into the nearshore stuff, and also unmanned surface vehicles, as well as drones using photogrammetry and LiDAR. So we did a case study in 2015, which provided really good results. So this is an area down in south of Ireland where we had where we did a lot of we had a lot of time. There's a lot of bad weather, so we did a lot of shallow water surveying with the boats, and then we got a drone survey to match it up to do a comparison. And we had very good agreement with the photogrammetry and the bathymetry data. So we decided to take it forward and invested in training and equipment. So now I'm going to talk about contrast two case studies. So this is Dublin Bay South, which is in controlled airspace in Dublin Bay. And this is a survey that took about 10 months to do to try to, first of all, we had to apply for IAA permissions. So we had to kind of build up our experience in dealing with the Irish Aviation Authority. So initially we'd apply for short operating windows, and then as they got more comfortable with us and we got more comfortable with the system, we gradually extend our request to operate for larger areas or longer times and that sort of thing. And we also had to plan this around low spring tides because we wanted to get as much of the intertidal area as possible. So some of the issues involved in a survey like this is that you want to kind of get your timing right, because you don't be stuck out when the tide is coming back in. So you've got to be aware of access and when the tide's going to change and staying safe. And then another issue in terms of the photogrammetry aspect of a job like this is homogeneous sands. So you can see that there are some broken areas there where there was obviously drone coverage, but the sediment was just too homogeneous for the photogrammetry to work. So then this is another example. This is down in the southwest of Ireland in an area called Glascarrig. It's a similar area. It's maybe about 10 kilometers of coastline. But this was actually acquired quite differently. This wasn't in controlled airspace. So Ballinskellig is about a 4.5-hour drive from Dublin. So when you get down there, you want to get as much done as possible. So we went down over the Maybank holiday weekend, and we had the advantage of long summer days. So all we really had to do when we were down there was find landowners and look for permission for takeoff and landing sites, and then look for appropriate sites to place our checkpoints, which would cover a range of ground types and elevations. So all those stars there are approximate takeoff and landing spots. And we covered this area in 3 days. One of the big issues with doing a job like this for large area mapping is your control software, so your laptops. So, if you've got any kind of technical issues, you're generally in the field going to get an hour and a half out of a laptop. You want a bit of redundancy there. So one of the things that this led us to do was to buy a Toughbook with hot swappable batteries so that we could get the most of our time in the field. So there's always issues. So as I mentioned there, there's the Toughbook with hot swappable batteries, which help us stay operational longer. One of the surprising issues in this job was that it was so sunny that the EB, the fixed wing drone we were using, was overheating when left in direct sunlight. So we had to actually put it away, wait for it to cool down, and then take it out as soon as we're ready to fly. And then there is also airspace infringements, which are a regular occurrence even in controlled airspace in Dublin Bay. We had the Garda helicopter fly through, the police helicopter. So we had to land, get out of the air, wait for them to do their business and get out of the way, and then we were back up again. One of the other lessons learned from large area mapping is not to mix up your headlands. So this is down in Bunmahon on the south coast. We might be good at making maps, but we also have to be able to read them. You can see there's a gap there where we didn't quite get the coverage that we thought we were getting. So I'm going to talk now about some time series work that we've done down in Rosslare in the southeast. So we've gone back to Rosslare and got time series data over 4 years, and this is the sample data that I'm going to take you through and cloud compare. So you can see here that we can digitize vegetation lines, and that we're getting up to and above 10 meters of lateral erosion over this period. What's interesting about this site is that there's a single track railway line leading from Rosslare Harbour all the way up to just south of Dublin. And at the current erosion rates, it's looking like this railway line will be inoperable in about 10 years. So if we want to look at a bit more than lateral erosion, we can use software called Cloud Compare, which will give us 2.5D volumetric analysis of the change. So this is a surface of change, and you can see along the coast areas where there's been significant erosion. So what I'm going to do now is I'm going to run through the Cloud Compare software. So I hope some of you will find this interesting. It's quite intuitive software to use, and I think it can be valuable for some people, particularly for detecting change and for visualizing change. So I'm going to run through just briefly how to use that software now. So obviously download and install it, and then file open, navigate to your data. You'll get these two pop-up boxes. So the first one on the left there is just the various things that you can bring in. So you can apply all and bring in your RGB fields and that sort of thing. And then an important thing to remember is that Cloud Compare works in a local coordinate system. So if you're bringing in multiple data files, you must select last input so that the same translation is applied to all the data that you're bringing in. So this is the main kind of viewing. This is the main software interface. So you've got your main viewing screen there with the data in it. Then on the top left, you've got your data window where you can toggle on and off your data sets. It's also where you select the data sets that you're going to work on. And then in the bottom left, at the very bottom, you've got your console, and the bottom left, you've got your properties window where you can manipulate viewing properties, looking at scalar fields and change color scales and that sort of thing. So once you've brought in your data, you want to basically clean it up so that you're comparing stuff. There's no point in comparing stuff that doesn't overlap. So you're going to segment your data. So there's this, you select the point cloud you're going to work in this case 2017, and there's a little scissors icon up there which will bring up the segmenting tool, and then you draw a polygon around your data, and you can segment in or segment out, but there's that polygon there is segmented in. And then you confirm your segmentation. And then you want to do the same for your 2020 data so that you're comparing, there's as much overlap as possible between the data that you want to compare. So the next thing you want to do is you want to align your point clouds. Now, even though both of these point clouds are georeferenced, it's still better to align them. You get more accurate results in Cloud Compare if you align your point clouds. So you can see the icon up there that finally registers already roughly aligned point clouds. And the important thing here is that you select an overlap that's suitable for the data you're working with. Generally for this erosion work, 50% is ideal. And the overlap, the final overlap that you choose will have an effect on your results. So 50% is a good one to go for erosion work. You can see the impact here. This is after the alignment, you're getting a root mean square of your accuracy after various percentages of overlap. So over on the left, you've got 10% and you've got very low root mean square error. Middle is 50%, 20 centimeters. That's kind of in and around the accuracy of the data. So you're kind of happy enough with that. When you go to 90%, you've got much more error. That's worked out on the remaining points after the alignment as well. So a useful thing about Cloud Compare is that you can do a volume analysis. So you select your 2 point clouds over on the left, up to the tools icon, select volume and compute 2.5D volume. So a few important things here. You want your kind of source data, your ground before, or the original data that you're working with, the larger area, I suppose, to be your reference. So that's the ground before up the top, Ross layer up the top on the left. And then you've got your sealing after is your newer data where erosion has taken place. Then your step size is your resolution. So the smallest step value possible should give you the most accurate result, but it's limited by the density of the point cloud itself. 15 is good for this data, so it's 15 centimeter step value. And then you can click the update button and you get your volume calculation there in the results field. And then you can also export that as a grid. So again, when I was saying about your theoretical overlap, you get vastly different volumetric answers depending on your overlap. Again, 50% kind of makes sense here. The middle one, you've got a volume loss in that area of about 1,000 cubic meters. If we want to see if that makes sense, you're kind of looking at 10-meter lateral erosion on a 10 to 12-meter high cliff. Over the you can see the change in the area there. Probably is the most accurate of the percentages that you're looking at there. The most accurate volume, about 1,000 cubic meters. So then you can visualize your results to see if they look like they make sense. That's the 2017 data. That's the change. That's your 2020 data. That's the change again. Then you've got different viewing panel, quick view perspectives over on the left there, so you can quickly change your view. And you can also manipulate your scalar field to change color scales and that sort of thing as well. So what I like to do is I like to show erosion in red and accumulation in blue. So there's a standard blue, green, yellow, red color scale in there. And I just make a copy of it and basically invert it so that you've got your erosion in red and your deposition in blue. And that's how you invert your color scale there. So that's really it. I just want to give a quick run through on Cloud Compare. Future for GSI and CHERISH plans would be hopefully integrating mobile mapping LiDAR systems, aerial LiDAR, UAV data, and laser scan data with the marine data. Try to close the white ribbon. So yeah, I hope you found that useful. And if you have any questions, work away.
Okay, thanks, James. Well, that wraps up the workshop. I mean, the three of us will still be around for 5 or 10 minutes or so if anyone has any questions, or have any discussions about any of the stuff we've talked about, clarify anything we've discussed.